All right, now here's something called a standard form. Here's a standard form equation of a circle. It's a bunch of x squared, y squared, xy, and a bunch of numbers in front of it. We call these coefficients, okay? Any equation that looks like this is an equation of a circle, but it's in standard form. The commonality that you always want to look for is that x is squared, y is squared. This one, x would be squared, y would be squared. That's always what you want to look for to tell whether this is a circle or not. So then, here's an example. Here's an equation of a circle because x is squared and y is squared. I know that this is going to be a circle. We're given a standard form. Now we're going to change it to graphing form. And guess what? When do we ever see an equation, like if we start with x squared plus 6x plus 5 equals to 0? How do we ever turn it into perfect square form? You guys remember what we did? Yes, hopefully you guessed it right. We did completing the square. We did completing the square to turn an equation into this form. That's exactly what we're going to do. We're going to do the completing the square to turn the equation of a circle to graphing form. So here's what's going to happen though. Because you have both x and y, you have to complete the square twice. Complete the square 2 times or twice for both x and y. Okay, so let's do it. Here's the first thing. Let me write the equation. X squared plus y squared minus 4x plus 6y minus 3 is 0. So then what was always the first step? Well, we always move the constant over. So that's going to stay the same. We're going to do the same thing for this one. Move the constant. And then we got x squared plus y squared minus 4x plus 6y equals to 3. And then what I'm going to do is, because this is a mix of x and y, we're going to put them together. As in, I'm going to put the x's together, x squared minus 4x. And then I'm going to put the y's together, y squared plus 6y equals to 3. And I left some spaces at the end because I got to complete the square, right? I got to add b over 2 squared to both sides to make a perfect square. So here, b is -4. Half of -4 squared, that's +4. I'm going to add 4 here, which means you do the same thing on the other side. You should also add 4 here too. This is what many people often forget to do. Okay, don't forget, added 4 on both sides. And then half of 6 squared, that's 3 squared, which is a 9. We're going to have to add 9 both sides as well. Always have to do it to both sides. Adding 9 both sides. So far what we have is we got x squared minus 4x plus 4. We completed the square for x. And then we got y squared, sorry, there should be a plus sign, y squared plus 6y plus 9 equals 3 plus 4 plus 9, which is going to be 16. We completed the square for the y. And we just got to write it in factor form, perfect square form. That will be half of -4, so x minus 2 plus y half of 6 positive 3 squared equal to 16. Here is the graphing form equation. We got a circle with center at 2, -3. And since this is the radius squared, radius would be square root of 16, which is gotta be 4. And we can graph it. Center at 2, -3. And radius is a 4, so I'm going to go up 4. Right, 4. Down 4. and left 4. Here is the circle, and we always want to make sure that we label points on the circle. This is 2, 1, 6, -3, 2, -7, -2, -3. Okay, that's it. So what I'm going to ask you to do is now do number 18 and 19 from chapter 7 in your notebook. I'm going to have you do that right now because first, those are 2 problems from tonight's homework. I want to make sure that you understand how to do those problems because they're very similar to the 2 problems that we did in class together in the video. So pause the video. Do these 18 and 19 from tonight's homework on your own first. You can come back to the video and watch how I did those problems. Okay?